If you're developing software for safety applications, high reliability, and you're doing it in C or C++, MISRA C and MISRA C++ are standards that you may want to work in. So, Andrew, why would I want to use these as opposed to just programming in C and C++ all by myself?
A lot of this comes down to experience, and a good experienced C programmer knows the things they shouldn't be doing. But MISRA, and in both its C and C++ versions, brings together the knowledge and wisdom over many years of people who've made those mistakes. And it was described in a conference a few years ago that the MISRA C and MISRA C++ are like having a code review of a set of world experts in the language doing it for you.
Mm-hmm.
So MISRA brings that experience into a set of rules to help you not make the mistakes that many of us have gone through and made before. And of course, increasingly, the functional safety standards are recommending the use of a subset of the language, and that's not just for C, but for other languages as well. And MISRA C, MISRA C++ brings together a very well established and very well recognized set of guidance for those two languages.
I've been programming in C for a while, and obviously, with a lot of experience, you tend not to make certain kinds of basic errors. Why should I want to be using something like MISRA C?
Quite often we make particularly silly mistakes because we just get into a rut and we're doing things and we overlook some of the basic stuff. Even experienced people make mistakes. And, it's not unheard of to look at a piece of code and start with which idiot wrote this piece? Oh, I did this morning, and teams are made up of really experienced people through to, new programmers. And C particularly is full of some real subtle, strange behaviors. Never mind C++ with some of its completely and utterly weird and wonderful behaviors. I'm not sure there are many people who honestly can claim to be C++ experts and know everything. So, the guidelines provide those little flags for things that, yes, the old and bold amongst us shouldn't make those mistakes, but we still do. But it's also a good way of encouraging and developing and teaching the new guys how to write code and to avoid those pitfalls.
How would I wind up getting started using MISRA C? Is this something where there are open source ones available, or maybe the compiler or tools that I'm already working with have something like this in it?
Many of the compilers, particularly in the safety critical domain and the embedded world, include limited subsets of the MISRA rules. Tools such as the Eclipse, tasking Eclipse will have them built in. Some of the embedded compilers, Green Hills, IER, those sort of tools have limited checks built in. If you want a full implementation, then really you need a good static analysis tool. There are a couple of open source tools out there. I can't speak for their completeness, having never used them, although we did release a set of rule headlines for CPP check recently. So there's an official MISRA header for CPP check, which some people are already using. It's like, how do you learn C is the best ways to be taught how to do it, and work with people that are doing it. And the same applies for MISRA. And, without doing too big a sales pitch, there are training courses available for MISRA, but basically write some code and analyze it with a tool is probably the best way. Oh, and read the book. It's surprising how many people, their experience of MISRA is looking at the results of a tool. They've never actually looked at the book. And the book has some really good rationale of why the rule is there, not just what the rule is for.
How would I potentially utilize MISRA C if I'm bringing it in? Is this something where it's going to wind up kicking out a lot of notifications that I'm going to have to address? Can I incrementally move my software into this?
Within our MISRA compliance document, which outlines the process of how you achieve full MISRA compliance, we deal with the topic of what we describe as adopted code. And that's for anything that either pre-exists the current project or is brought into the project from outside. In the case that, it's a legacy project where the code's already written, the reality is fixing MISRA violations may actually cause more problems than MISRA itself is detecting from weird and wonderful. So we apply a common sense approach there. Yes, you would need to comply with all the mandatory rules. Hopefully you are anyway. You would need to comply with the required rules, or at least document why you're not fulfilling them. In the case of adopted code, we would apply a general, use some common sense about the advisory rules. Some of them will give you lots and lots of warnings, but you could probably filter those out very quickly and decide which ones you want to address and which ones you're content to just accept. Obviously, if you're developing your code further, you may want to then look at those advisory rules again and review which ones you may have disapplied and seek to reapply them again. So yes, there is an incremental approach. And as with any regulated software, which typically, if you're in the safety space, you talk to your assessor and see what they will accept. MISRA is not just a box ticking exercise. It's all about understanding the rules and what they're trying to achieve. And the idea of 100% compliance with no deviations, it just doesn't happen.
For application spaces like automotive, where MISRA C sort of grew out of, it's a requirement. But what about everybody else? There are a lot of spaces that don't require it, but why would I want to use it in those spaces? Am I going to get better quality code, fewer bugs, something like that?
Well, hopefully, yes. A lot of the other standards, whether it's DO178 in the aerospace world through to IEC 61508 and its various derivatives, they all have requirements of how you verify and validate your code. Now, DO178 doesn't tell you how to do it. It tells you what you have to achieve at the end. And, the best way of achieving many of those requirements is through static analysis. Static analysis requires a set of rules. So if you need a set of rules, it's probably good to adopt a published, recognized, accepted set of rules rather than try and make up your own. So yes, there are other alternatives to MISRA, but MISRA itself has become that de facto accepted trans-industry set of requirements, and hence people have adopted it.
Would your recommendation be for those people that are in other industries adopt MISRA C? And likewise, for new programmers that are picking up C, do you think it'd be better to learn it from the get-go?
Certainly for other regulated industries where the requirements are ultimately the same as automotive, we want safe, secure, reliable, predictable software, then absolutely. For newbies coming to C or C++, there is a lot of educational value in understanding the rules and why we have them. So I think a newcomer to C would do worse than read the book to understand what we're trying to protect against. Because the problems arise whether you're writing ordinary desktop code or, flight critical software. You don't want things to go wrong.
Yeah, well, it also sounds like it's a good idea simply because the process using or following these rules is going to make you a better programmer in general.
Yes, absolutely.
What do you do if you, as a programmer, see the value in using C and C++, but it hasn't yet been adopted within your company? How do you convince those higher ups that this is going to be something that's going to be beneficial to our development?
The simple answer is you need to be able to show the value add. Recently, and obviously I can't name names for this bit, we were talking with a company where the management weren't sure that adopting static analysis, and MISRA in particular, was a good idea. So while we were talking with them, I got a copy of their source code sent to me, analysed it, and sent them the results, in a matter of minutes. And this was code that had been through all their internal procedures and code reviews. And it was, oh, we'll have a license, please. So the pure value add of a good static analysis tool with good rule sets, it's up there. And you will be able to detect issues far earlier in your project life cycle, things that probably won't get picked up in manual code review. Yes, they may eventually be found during testing, but that's well down the project life cycle. So good static analysis with a good set of rules such as MISRA, shifts all those problems right to the left. You find them earlier, you fix them earlier. It saves you time, it saves you money.
That sounds like a good reason to adopt it. Thanks for filling in some of the blanks.